Welcome to Maths with EJD. In this video, we'll be talking about measures of position. In the previous one, we already talked about measures of central tendency or location, which include mean, median, and mode. So let's go ahead to see what measures of position are. And don't forget to subscribe to this channel, hit the notification bell so you can always get alerted each time a new video is released. So measures of position. Measures of position help us understand the relative standing, the relative standing of individuals, or rather individual values in a data set. So that's to say that each value in a data set actually has its own position in the data set. Okay. So measures of position actually partition data, they partition data into equal groups and equal groups, okay, and are crucial for interpreting and comparing data, especially in terms of percentiles. So like the measures of position are basically there can be as many as possible, but the key ones are percentiles, deciles, and quartiles. So, for instance, you must have come across the idea of using percentiles to show the standing of students in student performance in exams like GRE, IELTS, SAT, and so on and so forth. Okay, so especially in terms of percentile, deciles, and quartiles. Now, these measures provide insight into how specific values relate to the rest of the data sets. So a student writes an exam, for instance, and they score they have a particular score. So you can use percentiles to know their standing. For instance, you say, maybe when you say a student is in the 80th percentile, it means that that student is actually performed better than 80% of all of those who took the exams, right? So I think it's the same idea of cutoff points for university matriculation exams like in Nigeria. So that's the idea. So these measures provide insight into how specific values relate to the rest of the data set. So let's look at how all of this apply to both ungrouped and grouped data sets. So um let's start with percentiles. First one, percentiles. Okay. So percentiles, you can see the keyword is percent, right? And that is cent is 100. So percentiles divide the data set into 100 equal parts. And the piece percentile, the piece percentile is the value below which P of the data lies. So for instance, if we say the 50th, let's say the 70th percentile, for instance, is the value below which 70 of the data actually lies. Okay. So the pitch percentile, for instance, is higher than 70 of the data you have. Okay. So let's try to calculate percentiles for uh ungrouped data. Ungrouped data. Okay. So here consider 25, 27, 30, 35, 40, 45, 50, 55, 60, 65. Now, this one has been arranged for the sake of to make it easy. So just like in the case of median, it is you always need your data to be arranged in ascending or descending order, especially in ascending order, to be able to calculate percentiles, right? So here you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So you have 11 data points, so to speak. So in this case, if you want to find the 30th percentile, 30th percentile. So it means you're saying that 30% of the data will lie below this particular value. All right. So let's see. So that's like what you can call P30. P30 is actually 30 over 100 times n plus 1. That's the number of data plus 1. And that is the 30th percentile is actually 30 over 100 times n plus 1. That it's about position, right? So whatever you get there, that position, that position in the sorted data, Okay. So that means that P30 is equal to 30 over 100 times n plus 1. You know, n is actually from here, n is 11 because we have 11 data points. So that's 30 plus 100 times 11 plus 1, you know. So, and that is 30 over 100 times 12 over 1. So this cancels this. So you have 3 times 12, 36 over 10. So it means you have 3.6, 3.6 position. Okay. So, and what that means is that you are going to have P30 to be, so that's 3.62, right? So that will be, N is 11, as we know already. So we have P30 to be 30 plus 0.6, 0.6 times 35 minus 30. Okay. So 3.6, right? So that, that is 1, 2, 3 covered. Okay. So that 0.6 is what we are concerned with now. So to get the 0.6 part of the story, so 3.6 is the position. So you have first, second, third. Then the 0.6 part is what we are taking care of. So take care of that 0.6 part. That is something between 30 and 35. So that's why you have 0.6 times 35 minus 30. And that is 30 plus 0.6 times 5. That is 3. So you have 30 plus 3, and that is 33. So it means that the 30th percentile is actually 33. So it means that 33 is bigger than is bigger than 30% of all the data. So that means that, look, if these are exam scores by students, right? So anybody who scores 33 is actually is in the 36th, is in the 30th percentile of all the performance, meaning that the person is better than 30% of all people that took the examination. So that's what that means. So let's talk about grouped data now. Grouped data. So, if this were to be a whole number, if the answer, for instance, was 3, the 30th percentile would just be 30 straight. But if it was 4, for instance, the 30th percentile would be 35. That's the fourth number in the series. I mean, in the data. So that's how that goes. So talking about grouped data now, let's imagine that we have class interval, and then we have frequency. Okay. So that is 10 to 19 occurring 3 times, 20 to 29 occurring 5 times, then 20, 30 to 39 8 times, then you have 40 to 49 10 times, and lastly 50 to 59 4 times. So if you have this data, which is grouped now, you need to find, let's assume we want to find the 60th percentile. You say to find the 60th percentile, that is the score that is better than 60% of all the data, of all the results. So to find the 60th percentile, the first thing you do is you compute cumulative frequencies. Compute cumulative frequencies. This is somewhat close to the idea of median, but not exactly. Compute cumulative frequencies. Okay, that's the first thing to do. The second thing is find the class where the cumulative frequency, where the cumulative frequency, find a class where the cumulative frequency exceeds 60% of the total frequency, of the total frequency. Okay. Then 3, apply the formula, for grouped percentiles. And this is the formula. P60 is equal to L. That is the lower boundary of the 60 percentile class or something like that. I mean, the class where the 60% of the cumulative frequency lies. All of that plus N times 60. N is the total number, the total frequency, all over 100 minus F. F would be the cumulative frequency just before the point you want to talk about. Okay. Then all of that multiplied by H, which is the class width, over F. That should be the frequency of the actual 60% class. Okay, so with what we have, let's work on that. Okay. So we have the class interval 10 to 19, 20 to 29, 30 to 39, 40 to 49, 50 to 59, Okay, and then you have the frequency. That's 3, 5, 8, 10, and 4. Then now you need the cumulative frequency. In the cumulative frequency, which we are going to get in a moment. Okay. So the cumulative frequency, just like I've always explained, it's for the first one, it's just 3. So the second will be 3 plus 5, and you get 8. The next one will be 8 plus 8, and you get 16. The next one will be 16 plus 10, and you get 26. The next one is 26 plus 3, and you get 30. So it means that your n here is actually 30. So now if you look at 60%, 60 over 100 of 30, 60 over 100 of 30 is actually 18. Okay, that's where the cumulative frequency is around 18. And this is 16 already. So it means that 18 is within this group. So we have identified a group. It is just like identifying the median class, so to speak. So it's like here, it's like the 60% percentile class. So if I'm going to give meaning to all of these things, for instance, so we say L is the lower boundary of the 60 percentile class, 60 percentile class, or if you like group, and N is total frequency. If you add all the frequency, then F, because F will be cumulative frequency before the 60 percentile class, before the 60 percentile class. Then H is class width, like we know. That's what we've been doing with group data. And of course, F would be frequency of the actual frequency of the 60 percentile class. Frequency of the 60 percentile class. Okay. So here we have seen that 60% of the whole data will be around 18, and the group has been already identified. So we can say that this group is actually the 60 percentile class. 60 percentile class. For 60% of all the frequency is 18, and it lies in that group. So having identified all this now, we can go for what we want. So you see that P60 again is L plus n times 60 divided by 100 minus big F times the class with H over small f. So P60 is equal to, so the 60 percentile class is 40 to 90. The lower boundary is 40 plus n. N is 30. N is 30 here. That's the total cumulative frequency. So n is 30. So we have 30 times 60 over 100 minus the cumulative frequency before that group, and that would be 16. Before you get to the 60 percentile class, the cumulative frequency is 16. So we have this 16 times the class width. Of course, the class width H is 59 minus 50, or 90 minus 10. That's simply 9. Okay, so we have 9 divided by the frequency of the 60 percentile class. That is actually the frequency of the 60 percentile class, not the cumulative frequency. That will be 10. Okay, the frequency of the 60 percentile class, that is 10. not, so we have to be careful. It's not 26, it's actually 10. So we have 10 there. So that is 10. Okay. So we can tidy things up now. P60 is now 40 plus 30 times 60 is 1,800 divided by 100 minus 16 times 0.9. 9 over 10 is 0.9. So P60 is equal to 40 plus 1,800 divided by 100. That's 18 minus 16 times 0.9. Okay. So P60 is equal to 40 plus 2. 18 minus 16 is 2 times 0.9. So that means P60 is equal to 40 plus 20 times 0.9 is 1.8. So that means that the 60 percentile is 41.8. So it simply means that 41.8 is bigger than 60% of all the data. That is what it simply means. So if this is talking about exam score, so it means that anyone who scores 41.8% has performed better than 60% of everybody who took the examination. Okay. So it's a bit tricky to unpack, but it's I mean, just follow through. You can go over it as much as possible to actually get it clearly. Okay. So that's about percentiles. So we can go on and on. Interestingly, the idea applies to others like this, except that as far as you know the context of those other ones, you can actually do the same thing always. So having talked about percentiles now, I'll go on to talk about deciles. Percentiles divide the data set into 100 equal parts. Okay. So what about deciles now? Deciles. Deciles. So for deciles, we say that deciles actually divide the data into 10 equal parts. Okay. Deciles divide the data into 10 equal parts. So, just like percentile. So for percentile, like we already considered, percentile will be something like, if you're going to talk about percentile, so you have P1, that's first percentile, second percentile, third percentile, up to 100 percentile. Okay. But for deciles, now since deciles divide the data into uh, 10 equal parts, so it means you can have so now it will be D, right? You have D1, D2, D3, and it goes on until you get to D10. Okay, that's what you have for deciles. So deciles divide the data into 10 equal parts. So the first decile, that's D1, corresponds to the 10th percentile, interestingly. So D1 now is that's 10 equal parts, right? That's 1 over 10 of the whole data. And 1 over 10 of the whole data is like 1 over 10 of 100, which is 10. So in that case, that means D1 corresponds to the 10th decile. I mean, to the 10th percentile, actually. So you can see the connection. So first decile is the same thing as 10th percentile. D2 to the 20th percentile, to the 20th percentile. So the second decile corresponds with the 20th percentile, and so on and so forth. So at the end of the day, you can still relate everything back to percentile. Okay. So let's look at a case for ungrouped data and see how that looks like. So ungrouped data now. So uh, ungrouped data. So imagine this data, 5, 8, already arranged. If it is not already arranged, you have to arrange it in ascending order, strictly. So 5, 8, 12, 15, 20, 25, 30, 35, 40, 45. Okay. So here, n is equal to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. So you have 10 data points. All right. So if you want to find the seventh decile, the seventh decile, that is simply you looking for D7, right? The seventh decile, that is 7 out of 10. So just like the formula is pretty much the same like before. So the seventh decile from this data would just be 7 over 10 times n plus 1. Okay. So that's the position, that position. So if you get the result straight, you just, so if you get like 5 now, that means the fifth position. So you go 1, 2, 3, 4, 5. But here, let's see what we get. So D7 would be 7 over 10 times n is 10. So we have 10 plus 1. Okay. And that will be D7, which will be 7 over 10 times 11. So don't forget it is position, not the face value. So the position. So D7 is actually 7 times 11, 77, divided by 10. It's position. Okay. So D7 is actually 7.7th position. So normally, if the answer was 7, you just count 1, 2, 3, 4, 5, 6, 7, and this is your answer. But no, if it was 8, the answer would have been 35. So it means that the 7.7th decile is between 30 and 35. So what do? We go for D7 now. You know, the seventh, this is 7.7. So you take the seventh thing, the seventh number data 1, 2, 3, 4, 5, 6, 7. That's 30. So you pick that. So you have 30 plus. So this 0.7 now you have to deal with it. So you have 0.7 times then it lies between 30 and 35 because this is the seventh thing and this is the eighth thing. So it means that the 7.7th thing will be between 30 and 35. So that's why you have 0.7 times 30, 35 minus 30, okay, to get the actual value now. So D7 is 30 plus 0.7 times 5. Okay. So D7 is 30 plus 0.7 times 5 is 3.5. So the seventh decile is actually 33.5. So it means that if those were exam scores, anyone who scores 33.5 has performed better than uh than 7 over 10 of the whole population, which is the same thing like 70th percentile, right? So, I mean, that means the performance in the exam was really not so good, you know. So that is how to go for ungrouped data. So if we use group data, right, like before, so if we talk about grouped data, so let's use the same data like before. And we want to find the the eighth decile, which of course is similar to 80th percentile, is the 80th percentile. Of course, this is the eighth decile. The eighth decile, the same thing as the 80th percentile. So now let's go to that thing again. Let's go to the table. Of course, before we even go to the table, let's write down the formula. The formula is just like what we had before, except that there'll be a bit of adjustment. So if we have D8 now, D8 will be the lower boundary of the eighth decile class, okay, plus the total cumulative frequency times 8 over 10, 8 decile, minus the cumulative frequency before this class, times the class width, divided by the frequency of the 8th decile class. Okay, I guess I need to write that out for clarity's sake. So L is lower boundary of the 8th decile class, of course, which you have to find. Then big F is cumulative frequency before the 8th decile class, for the 8th decile class, then you have, of course, H is the class width, which is regular, okay? And then you have small f, that is the actual frequency of the 8th decile class. So it looks like the most important thing you have to be able to find is that 8th decile class. Once you find that class, every other thing is associated with it. So f is the frequency of the 8th decile class. So let's go back to what we had before. You had CI, and then you had frequency, and of course you're going to have cumulative frequency in this case. So you have 10 to 19, the frequency is 3. You have 20 to 29, the frequency is 5. You have 30 to 39, the frequency is 8. You have 40 to 49, the frequency is 10. Then you have 50 to 59, the frequency is 4. Okay. So let's get the cumulative frequencies. Of course, this is just 3 straight up. Then here 3 plus 5 is 8 again. 8 plus 8 is 16. 16 plus 10 is 26. 26 plus 4 is 30. So again here, oh, okay. N, I forgot to talk about N. N should come before that. So N is total frequency. Okay. Total frequency, or total cumulative frequency, if you like, right? So here, N, okay, first of all, N is 30, okay? So the the eighth decile class can be computed from 8 over 10 times N, okay? That is 8 over 10 times 30. That is 24. Okay, anywhere 24 lies for cumulative, that is your 8th decile class. Okay, that's your 8th decile class. Interestingly, it's still the same place because after 16, so after 16 you have here 17, 18, 19, 20, 21, 22, 23, 24, 25, 26. So 24 is still here. So again, coincidentally, the 8th decile class is still the 40 minus 49 class. Okay, so that means that okay, if I write the formula again, since we need D8, that is L, that's the lower boundary of the 8th decile class, times N times 8, N times 8, all over 10, minus big F, that's the cumulative frequency before that point, then class width divided by frequency of that class itself. So it means that D8 is equal to the lower boundary of the 8th decile class is 40. That's 40 plus N is 30 times 8 over 10 minus the cumulative frequency before that class again is still 16 times. It doesn't always have to be like this. Just follow the data. So the only thing is that most times when the group with the biggest frequency would most likely fall into the same range. So the class width again is 9. Okay. H is, if you like, 19 minus 10 or 29 minus 20, that's 9. Okay. Then okay, of course, the big F, which I've not written out before, is 16. That's the cumulative frequency before the 8th decile class. The small f is 10. That's the frequency of the 8th decile class. Okay. So we have identified all that. So H is 9, F is 10. So the 8th decile is 40 plus 240 over 10 minus 16 times 0.9. So D8 is equal to 40 plus 24 minus 16 times 0.9. So that means D8 is equal to 40 plus 24 minus 16, that's 8 times 0.9. So D8 is equal to 40 plus 0.7. Is it 0.72? No, 7.2, that is 7.2. And the eighth decile will be 47.2. Okay. So, of course, don't forget, eighth decile is 80th percentile. That means that anybody who scored 47.2 has performed better than 80% of everybody who took the examination. Okay, that is how to go about that for grouped data. So, because you expect the 80th percentile to be bigger than the 70th percentile. The 70th percentile was 33.5. So the 80th percentile is 47.2. All right, let's go on to talk about quartiles. Quartiles, which are also important. In fact, the quartiles have they are relevant even in data analysis, in data science, machine learning, and all that. Because we got to talk about interquartile range when you want to make sure when you want to deal with outliers. Most of the times you get to use this. So let's talk about quartiles now. Quartiles. Remember, percentiles divide your data into 100 equal parts. Deciles divide them into 10 equal parts. Quartiles will divide them into 4 equal parts. Okay. So quartiles divide the data set into 4 equal parts. Into 4 equal parts. So the most common quartiles are Q1. Of course, like just like I've been saying before, this would be 4 equal parts. That's first quartile, second quartile, third quartile, fourth quartile, normally. Okay. But most times we don't talk about the fourth quartile. We talk about the first quartile. Q1 is first quartile. Okay. And that the first quartile is actually 1/4, right? Which is 25%. So this is actually 25th percentile, 25th percentile, or if you like, can call it the 2.5th decile, right? 25th percentile, which is actually bottom 25% of data. So that's bottom 25% of data. Okay. Then you have the Q2, which is the second quartile, which is corresponding to the 50th percentile, the 50th percentile. So that you can call the median. So you can see 50th percentile corresponds with median, or the second quartile, or the 50th percentile, or the fifth decile corresponds with the median. Okay. Then you have Q3. So in terms of decile, right? I said this is okay. Maybe I'll come to talk about that later. So you have the Q3, which is third quartile. That talks about 75th percentile. So that is actually top 25% of data. Just like this is median of data, right? So if you want to talk about them in terms of decile, this is like this is 70th percentile is the 7.5th decile. Okay. While the 50th percentile is the 5th decile, which is also the second quartile. The first quartile will be like the 2.5th decile. Okay. So they are all interconnected like that. All right. So with all of this now, can we look at how to apply this to both grouped and ungrouped data? So let's talk about ungrouped data first of all. So the approach is pretty much the same, except just understand the context in this case. So here, imagine you have 12 18, 25, 29, 35, 40, 45, 48, 52, and 60. So N is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 again. So N is 10. Okay. So if you want to find Q1, to find Q1, that is the first quartile. That is simply the Q1 equals 1 over 4, 4 equal divisions. That's 1 out of 4, or 25 over 100 times N plus 1. It's position. Don't forget, it's all about position. So that Q1 now is equal to 1 over 4 times 10 plus 1 position. Okay. So Q1 is equal to 1 over 4 times 11 over 1. Talking about position still. So that Q1 is equal to 11 over 4. 11 over 4th position, which is simply the same thing as 4 in 11 is 2. That's 8. 3/4 position. Okay. Of course, to make things more usable, that's 2.75th position. 2.75th position. So that Q1 will be in the second position in the data, you have 18. This is in the second position. So the fraction means you have the rest between 18. You have everything between 18 and 25. So that's why you now have 18 first plus the remaining 0.75. You have 0.75 times the difference between 18 and 25. So that's 25 minus 18, and 5 minus 18. So that means the first quartile is 18 plus 0.75 times, I think, 7, right? 7. Okay, yeah, 7. So that Q1 is equal to 18 plus, that should be 5.25. 7 times 5, that's 7. 5 times 7. 7 times 5 is 25. 7 times 7 is 49 plus 2, that's 51. 51? 7 times 7 is 49. 7 times 5, 35. Okay, you hold 3, sorry. 7 times 7 is 49. 49 plus 3 is 52. Okay, so 2 decimal places. So you have 52.5. You have 5.25 rather. So that the first quartile is actually 23.25. So it means that the bottom, so 23.25 is bigger than the bottom 25%. Okay. Now let's quickly talk about grouped data. So for grouped data now, grouped data. So talking about group data, we do just like before. So if you want to find Q3 from the same grouped data like that we've been using, the same grouped data. So if you want to find that, so okay, let's come with the data again. I'll just go straight. So okay, well, maybe we can write the formula, right? Q3 is the lower boundary of the third quartile group. Q3 is the third quartile. So the lower boundary of the third quartile group plus the total frequency n times third quarter, that's 3 over 4, right? Minus the cumulative frequency for the third quartile group times the class width divided by the frequency of the third quartile group. So at the end of the day, you just need to identify the third quartile group, basically. Let me go the extra mile to say this is lower boundary of the third quartile class, Okay. Then N is the, one easy way to do this is, third quartile is 75 percentile. So you can do it just like you're handling 75 percentile. I'm just being finicky about this to actually talk about the specifics. So N is the total frequency, or if you like, a total cumulative frequency. So total frequency. And then big F is the cumulative frequency, cumulative frequency before the third quartile class, And then H is the class width. Lastly, F is the frequency of the third quartile class. Okay. Frequency of the third quartile class. Now, let's have the table again. So we have the class interval, we have the frequency, we also need the cumulative frequency. So this is 10 to 19, which occurs 3 times. Then we have 20 to 29, which occurs 5 times. We have 30 to 39, which occurs 8 times. We have 40 to 49, which occurs 10 times. Then lastly, we have 50 to 59, which happens 4 times. So that we can now go on with the rest. So again, cumulative frequency, this is 3 plus 5, that's 8, plus 8, that's 16, plus 10, that's 26, plus 4, that's 30. Okay, so N, of course, again is 30. Then we need the third quartile class, right? So let's say Q3 class. Q3 class will just be 3 over 4 times 30. So that is 90 over 4. Yeah, which is 45 over 2. And 45 over 2 is 22.5. This is 22.5. So again, 22.5 lies within this range. So that means that this is still the Q3 class. Well, the reason for that is because it has the highest frequency. It doesn't always have to be like that. So please mind you, you can have another table and all the 3 things we found so far can be different classes. So just follow the values as they come. Okay. So we found a Q3 class. So that simply means that the lower boundary is 40. What else do we need? The cumulative frequency before that is still 16. The class width, of course, is 9. The frequency of the class itself is 10. This 10, not the cumulative frequency now, the actual frequency of that class. So now we can go ahead and apply a formula for Q3, which is corresponding to the 75th percentile. For the original formula, just put 75, that first one we ever did. So Q3 again is L plus N times 3 over 4. So N times 3 over 4, and the cumulative frequency before that class times H over F. So that Q3 now is equal to 40 plus 30 times 3 over 4 minus cumulative frequency before that class again is 16 times 9 over 10. And then we get moving. So Q3 is 40 plus 90 over 4 minus 16 times 0.9. So that Q3 is equal to 40 plus 22.5 minus 16 times 0.9. So Q3 again is 40 plus 22.5 minus 16 would be 6.5, I believe. Yeah, I think so. Times 0.9 now. So Q3 is 40 plus, it's just an aside, 65 times 9. 9 times 5 is 45. We're holding 4. 9 times 6 is 54. 54 plus 4 is 58, I believe. Yep, 9 times 7, 45, hold 4. 9 times 6, 54 plus 4, that's 58.5. So two decimal places, that's 5.85. 5.85. Two decimal places, because this is 1, this is 2. So we have 5, 5.85. So that the third quarter is actually 45.85. So anyone who scores 45.85% is better than three-quarter of the whole of all people who wrote the exam. If you're thinking about an exam, or 45.85 is better than 75% of everybody who enrolled. So that is the implication of that. So it's nice, right? To round off, let's talk about significance of measures of position. So let's quickly round off on that note. Significance. What's the significance of percentiles, deciles, and quartiles? Significance of measures of position. Okay. So first, let's start with percentiles. Percentiles. So just like I said before, they are widely used in standardized tests, standardized testing, e.g. in SAT, that's Scholastic Aptitude Test. That's like the exam you need to write to get into undergraduate studies in the US and maybe Canada, I think, especially the US. Then there is the GRE, that's the Graduate Record Exam. That's the exam you need to write to get into graduate school in the US. And of course, maybe GRE is mostly for science, engineering, and all that. And GMAT is for management, business studies, and things like that. So exams like that. You also have TOEFL, IELTS, and all that. So, um, so standardized testing, right? To understand how a student performs relative to peers, relative to peers. So when you get your result from this kind of exam, they tell you your percentile. So if you're in the 80th percentile, for instance, it means that you have done better than 80% of everybody who wrote the exam. Okay. So we say, for example, a score in the 85th percentile, a score in the 85th percentile means that 85% of students scored below that score. So, I mean, it doesn't mean that you have 85%, right? You can have, for instance, the last thing we did was third quartile or 75%, but the score is 45.85. So it's more like compared to the group you're written the exam with. Okay. So if the score is in 85 percentile, it means that you have done better than 85% of all the people who wrote the exam. That's basically what that is about. Okay, so let's talk about uh deciles. Where do we use deciles? Mainly deciles. So this is common. This is common in financial analysis. Common in financial analysis to segment data segment data into performance deciles, such as ranking stock returns or income distributions. Okay. So lastly, what about quartiles? Quartiles now. Quartiles. So for quartiles, this is essential. In descriptive statistics. In descriptive statistics. Box plots. We're going to be talking about visualization along the line in this course. So box plots and analyzing income inequality. E.g., we got to talk about interquartile range. I think I'm going to talk about this in the next video where we'll be dealing with measures of dispersion of variability. So interquartile range is one of those measures. So you have interquartile range, the spread of middle 50% of the data. Okay. I know even in economics, right? The middle class is such a big deal. So interquartile range gives us a kind of idea like that of something like the middle class in an economy. So because it talks about the spread of the middle 50% of the data. Okay. For instance, in finance, quartiles may show performance of a mutual fund, relative to others in its category. Yeah, so that's how it's been here. But then to sign off, understanding these measures of position helps in making sense of distributions and identifying where specific values lie within the overall range of data. So you want to be able to say, okay, this particular value in this data is in this position, and that's what we call the measures of position. Thank you for coming this far with me. If you have not subscribed to this channel, you can see that there's a whole lot to learn. You want to subscribe to this channel. You also want to hit the notification bell so you can always get informed whenever a new video is released. And of course, don't forget to comment, like, and share. See you later. Bye.